So people who have functional ankle instability are by nature unstable. So if you have them balance on one leg, they'll have difficulty doing that more than the average person. And we can measure that using an accelerometer. So an accelerometer is something that measures the acceleration of whatever you put it on in 3 dimensions. And we know that people who have functional ankle instability will exhibit more variability in their acceleration, which we call postural sway. So they will sway more than the average person, which again leads to that instability, which could potentially lead to falls. So that's what we call static stability. And then dynamic stability is stability in performing some kind of task. So like kicking a ball, landing from a jump, something like that. And again, people who have functional ankle instability are less stable when they do that. So, planting your foot to kick a ball, we might have no problem with that, but somebody who has functional ankle instability, again, is unstable and could potentially fall or just not perform the task at the optimal level. So an accelerometer acts very similarly to this pitcher of water, this glass of water. So if I'm holding this glass of water and I accelerate, something like this, the water is going to slosh in the glass. And what happens is if I accelerate this way, then the water is going to want to stay behind because of Newton's first law. And so it's going to slosh backwards, if you will. And so we can tell, if it's sloshing at all, we can tell if it's accelerating. So for example, if I'm not accelerating, if I'm moving it just at a constant velocity, there's no sloshing. Okay. Acceleration is what causes the sloshing. An accelerometer works exactly the same way, except instead of using the gravitational field, which is what is helping to kind of keep this water in its place, it uses an electrical field. So an accelerometer is an electronic device, and so it uses that electrical field, but in a very similar way to what I just showed you. A FitBit is an accelerometer with just some fancy interpretation software. So a FitBit measures acceleration like an accelerometer, and then what the software does is it determines what is and is not a step, which is more difficult than it may sound. Accelerometer data is very messy. There's a lot of peaks and valleys. And so the FitBit has to determine what peak is actually a step and what peak is just kind of noise. So like I said, the acceleration data is very messy. And so the software has to interpret, again, what is and is not a step. That's not necessarily a black and white thing, right? I mean, sometimes it says this is a step when it's not, and sometimes it doesn't say it's a step when it is. There's a lot of research, honestly, going on about the accuracy of these things, and what we're finding is there's a wide variation. So if you take a Fitbit and a polar loop and whatever, all these different activity monitors, and you put them in the same relative place, like you have somebody wear them on the same wrist, they're all going to have different measures because they all use different software to interpret that data. So it's kind of a question about what is the true data, what is really going on, how many steps are you really taking, and that's actually a pretty active area of research. Along with that, does more steps necessarily mean that you're exercising harder or exercising more? I mean, I can sit here and just do this, but because I'm seated, it's not really a lot of exercise. So again, there's a lot of research going on about relating those step counts to actual exercise output and seeing if they're more or less the same thing.